Okay, I tried problem 6.3 the other night and I was a little tired and got frustrated pretty quick, and it was simple mistakes. So just kind of proving the point that everybody gets hung up on different things. So we're millimeters, grams, and seconds. It is easy, but there are some geometries we have to look out for, and the watch out for the assumptions that get made. Origin is at the bottom center. Lines, circles, center lines, arcs, polygons, revolves, extrude, bosses, fillets, and chamfers, and planes. I'm not really sure what they're doing with planes, but um, we will go ahead with our build. So this is a part millimeter. We're opening on the top plane. We're going to go into the polygon. There are 6 sides. Inscribed circle, so the interior. And I'm going to go ahead and do both pieces of geometry. So first thing, I'll highlight and make horizontal, and then highlight and make horizontal, and then we'll go into the smart dimensions. So with the polygons, I like to just go ahead to the inscribed circle, and across the flats on the outside is 6 millimeters. Nope, that was the inside. So across the flats on the inside is 4 millimeters. So we'll double click, hit enter. Then we can go to the outside if you want to go across the flats. And we have our basic geometry. So let's go ahead and extrude. And since these are closed contours, it's going to make it hollow. But what I really want it to do is the contour for the outside first. So the overall is 17, and then the -4 will give us 13. And we'll go ahead and accept. Make sure to expand out, highlight the sketch, and we can go right back into the boss extrude. Number now is 17, and the contour is the interior, which gives us a little bit more. Okay, so that gives us our starter geometry. Now we need to create the chamfer on the bottom, and it is 1 millimeter by 1 millimeter, 45 degrees, 1 millimeter by 45 degrees. So if we just put chamfers on those, they're going to be, well, let's go ahead and put a chamfer on it, and we'll take a look at the result. So fillet, pull down, we go to chamfer, and it's 1 millimeter by 45, and then tab, and tab, and we pull up that geometry and go ahead and see what it looks like. So this makes it very squared off. The doesn't look like what we would expect from the revolve. So I'm going to go ahead and just delete that one, or Control Z. And from the front plane then we're going to go into a sketch. Let's see, the top chamfer is 0.5 by 45 degrees. So let's get into a vertical construction infinite length. Place it on the origin because that's going to be the axis of our revolution. And then I need 2 triangles. In the meantime, I have turned on the sketch numeric input, so show you what's going on there. I will do a little deeper dive into this. Enable on-screen numeric input on entity creation, create dimension only when a value is entered. So in effect, the sketch numeric input is toggled on and off here, but how it reacts is set in the options. So we have the 1 millimeter that grew a little bit different, so we'll make sure that I get that back to a coincident with with the lower edge. And then we're going to do the same basic thing up here, only 0.5 millimeter. So 0.5, if you're doing the click drag, make sure that you don't let go until you've applied the dimension. So 45 degrees, that looks good. All right, so for this geometry, we're going to go ahead with setting, let's see, we had the horizontal, no, okay, so we've got to come out some distance down and then create our arc. So for this one, we're going to bring the geometry out and then going in, and that should be complete. So let's go into, I'm going to do a 3-point arc just so I can connect the endpoints, and then by selecting on it, figure out, and with our numeric input, hit 4.5. All right, so that one got applied, but why didn't we, oh, I got an overall length somewhere. So let's go with, well, if that's tangent, that will determine the height. So let's go ahead and revolve cut 360 degrees and see what that looks like. So here's the issue with doing it that way is we don't really see those gaps. So we haven't really discussed a type of fillet that will do that, but let's just see what we get when we go to place our 1 millimeter fillet along that edge. All right, so that goes up and in. That's not really what I'm seeing or going from. So they haven't really introduced the face fillet. So let's see if the face fillet will figure out how to make that geometry. There's at least one face in there. Let's go ahead and see if it'll eliminate that. All right, so that geometry did not go in. Pretty sure that I can't just do a fillet that way. All right, so let's see if Feature Expert will try to figure it out. And could not finish the geometry. So if we were going to go to planes, we, I really want it to look like this. At some point that geometry looks okay, but if I really want it to look like this, then I'm going to need to come up with one more piece of geometry to work from. So taking a guess, we're going to go into the right plane, and that's normal to that face. And let's go with our line first, and bringing it out some distance. And then I would like this silhouette edge, so as you drag along the edge, you see that little cylinder with the line through it. That tells me I'm on the silhouette. Again, convert and offset does not, how do I put that, does not, shows that it is fully defined at the ends, but if you drag it, then it does allow it to move. So I did the 3-point arc, and just like before, we're going to connect the endpoints, make it tangent, and then we can go put a dimension on it. 1 millimeter. All right, so let's see what that looks like as an extruded cut going both ways, through all both. And that gives me the little teardrop, that transition teardrop shape. And to finish this out, then we don't really have a circular axis that we can use. So I'm going to go to the temporary axes, because that's going to pop up at least one. And we're going to find the cut extrude. All right, so select the temporary axis, control select the cut extrude, circular pattern. The axis comes up. We need a total of 6 of those. And let's go ahead and instant spacing or equal spacing. We want to do equal spacing. Not sure why that reverted back to instant spacing. Let's go ahead and see what it gets. All right, so now we can turn off the temporary axis, and we'll go ahead and save this. This is our 6.3. And oh yeah, that's for the 3D print. And level 6, P6-3. And there was my first try where I realized that geometry wasn't going. And actually I did it going the other way and ended up with an undercut. So it was interesting geometry to solve. All right, so we had 427 cubic millimeters. We're going to evaluate and go to mass properties, and we're at 427.4. So we will call that one good.